All right, so for number 8, we got h of x is given to us, and we want to graph k of x, which is h of x but transformed. So I'll show you a couple different ways you can do this. If you know your transformations, then you could just apply those, and then I'll explain like how that works. But so the transformations onto h of x look like you have a negative right there. So that is going to reflect your points over the x-axis. And then the -2 or the +2 is going to move all your points to the left 2 units. And then the -3 is going to move all your points down 3 units. So when you have to do these transformations like on a graph, what I suggest is take a couple points that you know like the coordinates of, like, so you got 2, 2. All right, so we'll do that point first. So if you take, that's not 2, 2, that's 1, 2. So if we take 1, 2 and then reflect it over the x-axis, then move it to the left 2, and then down 3, we end up right there. All right, so that's 1 point. And then let's take another point, like this one right here. Looks like it's at -4, 1. So if you take -4, 1 and reflect it over the x-axis, and then move it to the left 2, and then down 3, you end up like right around here. Okay. Let me color coordinate this. So that'd be this point here. Gets reflected. Oh, come on. Sorry. Reflected left and down, left 2, down 3, and ends up right there. Bless you. Bless you. Bless you again. Anyway, then let's take one more point. I mean, we can kind of see what's happening here. Let's take one more point. Let's take this one. It might come off the screen a bit, but that point is at 3, 8. So if you reflect it over the x-axis, it's going to be at 3, -8. And then move it to the left 2. And then down 3, it's going to be like somewhere over here. All right, so I went off the screen a little bit. All right, and then we could just connect those dots. And that's what it would look like. So I'll show you another way to do it, but let's do the domain and range. So the domain of the original function was all real numbers. So since we're only shifting it left and right, up and down, and reflecting it, it's not going to change it. And I can't think of a transformation that would change your domain if it's originally all real numbers. So it's going to remain all real numbers, because we can even see in our transform graph that it's, she's fine here. We can see in our transform graph that it's still all real numbers. Now the range of the original graph looks like it has a minimum. Now it's hard to get exactly, but if we just like estimate this point here at -1, 1/2. All right, so our original range was y is greater than or equal to 1/2. But then that gets transformed by reflecting this point over the x-axis. So it's at -1, -1/2. And then it moves to the to the left 2. So like right here. All right, so now that point's at -3, -1/2. All right, and then it gets shifted down 3 to like around here. So if it goes down 3, I didn't draw this perfectly, but if it moves down 3, it'd be at -3, -3.5. So like that's where this point would be after I do all the transformations. So then I would estimate the range to be like y is less than or equal to -3.5. And if I give you something like this for like on a test or something, I would make it like much more clear as to like what this minimum point was. So then you could do the transformations on that point to get like where the new maximum point is. We had to estimate this a little bit, which is why it doesn't look perfect, but that's how I would find the range. All right. Now, any questions so far? All right. Now, yeah, go ahead. Sure. I just wanted to show one more thing on this, and then I'll go over five. Just to like show you why the transformations work like this. So if I make a table of h of x, right, so this will help you see what happens. And I should probably do that over here. All right, so x comma h of x. So I look at the graph and I find a couple points. So we had -4 comma 1. Okay, that was like that point right there. We had this minimum point looked like around here at like -1.5 comma 1/2, so 0.5. And then we'll take another point like right here, like 2 comma 4. All right, now to understand like why we're doing the transformations in a certain order, this will help you understand that. So first thing I'm going to do is I'm going to subtract 2 from all of these x values. So I get -6, -3.5, and 2. And the reason why is because I want to find the y values for h of x plus 2. So I already know that h of -4 is 1, h of -1.5 is 0.5, and h of 2 is 4. So I want to get those same numbers inside my parentheses. So if I subtract 2 from all my x coordinates, then I'll get those values for x. So I get h of -4, which I know is 1. All right. And if I plug in -3.5, I'll get 0.5 because that will be h of -1.5. And if I plug in 2, I get, I never subtracted 2 from that. So that would be 0 here. So if I plug in 0, I would get h of 2, which I know is 4. All right. So these would be the points on h of x plus 2. All right. Then you could take all those points. So we take the same table, and now I'm going to take my y values and negate them. So the point -6, -3.5, and 0 for x. And I'm going to take all of these y values, which are represented by this, and put a negative in front of them. So I get -1, -0.5, and -4. All right. Then, last but not least, if I just add 3 to both sides, or subtract 3, sorry. So I subtract 3 from everything, I get my new points. So I get -4, so -6 comma -4, -3.5 comma -3.5, and 0 comma -7. Okay, so now if I plot these points like -6 comma -4, right, that's going to be like right around there. If I plot -3.5 comma -3.5, that's going to be like right around here. It's not writing. And then 0 comma -7 is going to be right over there. All right, now that's what this would look like after doing those transformations. So you can always make a table too. And the table helps you understand like why you subtract 2 from these x's when you're adding 2 in here. It's because you have to undo that +2. So you undo it by subtracting 2, and then you end up getting these same values inside the parentheses. All right. And then it's much more clear to see what the domain and range is. Domain over real numbers, range y is less than or equal to -3.5. All right, now let's do number 5. Yeah. Yes, probably. I'm just trying to end this recording. Stop sharing.